So what we're looking at last time, we had this animation going, and we were trying to make some observations and explain them. So we had, it wasn't the notes aren't brilliantly organized, but we had this animation where we were trying to see what happened when we added protons, when we added neutrons, when we added electrons, because the previous lesson we were trying to make this atom, lithium. Okay, it had a mass number of 7. There's its symbol, its name, and it's got an atomic number. And we were using the simulation to make it. So we realized that protons have a mass number of 1. Well, that was our explanation. So because when we added protons, the mass number went up by 1. So that must be one of the things. So protons have a mass number of 1. They also have a charge of 1 because when you added protons, the charge increased by 1. But we noticed when we added protons, the name also changed. So the name did not change when we added neutrons. Okay. It also didn't change when you. So I'm going to edit this now because we can say the name did not change when we added electrons. Okay, so let's go back to the explaining results again, and the name of the atom is entirely down to the atomic number, which is the amount of protons. So there is you can't have, so every single hydrogen atom, for example, has 1 proton. You can't have a hydrogen atom with 2 protons, but you can have a hydrogen atom with 1 proton and 2 neutrons. So I'll just quickly nip into this simulation and demonstrate what I mean. So we go to build an atom. So let's just get that up first of all. So when we added a proton, we said the charge went up by +1, the mass went up by 1, and the name changed to hydrogen. When I added a neutron, the name stayed as hydrogen. When I added electron, the name stayed as hydrogen. If I added a proton, the name changed. Took it away, the name changed again. So the name is entirely down to the number of protons. So what else did we? So that was about the name. What about the mass? The mass went up by 1 when we added neutrons because neutrons have a mass of 1. So yes, so the name of the atom is down to nothing, entirely down to the number of protons. Okay, you can't have, if it changed the number of protons, you will change the name. And if you want to change the name, the only way you can change the name is by changing the number of protons. The name did not change when we added electrons. Okay, yeah. The charge was not affected by the neutrons because the neutrons have no charge. Well, I'm explaining something again there, aren't I? So, yeah, and I can just put other observations. So, yeah. So basically, when we wanted to make our lithium atom, so I'll load it up here, and I'm just going to do the symbol for the lithium atom. This is the task that you had to do originally. Mass number of 7, atomic number of 3. I know I've got to make a mass number of 7. I know I've got an atomic number of 3. If it's got an atomic number of 3, it must have 3 protons. So 1, 2, 3. It says lithium, but I've got to, and the mass number is 3 because protons have a mass number of 3. Oh, sorry, protons have a mass number of 1. But I can't add more protons to increase the mass number because if I did, then the name changes. So I can't do that. So I have to add something else. If I add a neutron, the mass number goes up. So that's fine. I keep adding neutrons until the mass number is 7. So mass number is 7. It's lithium. So we've got the same right mass number. We've got the right name, but and the atomic number isn't there, but it's lithium has an atomic number 3. Now we just need to sort out the charge. So we've got 3 protons. If I add an electron, the charge, they start to cancel out. Add another electron. Oops. Cancels that again. and one more electron, and now we have a neutral atom. So how do you make a lithium atom? You're going to have 3 protons, 4 neutrons, and 3 electrons. So for example, if we had to make another one, if we had to make another type of atom, let's say, for example, beryllium. Beryllium has got a mass number of 5, an atomic number of 4. And if we have a look over here, in fact, there's another little trick here. When I add 1 proton, notice that one's coloured in, and it's called hydrogen. The next one along is helium. So when I add another proton, we get helium. The next one along into the next row is lithium. So that's lithium. Remember, if I know what element I want to make, I want to do nothing more than just start adding protons, and then I can see what I've got then. It looks like the next one's going to be beryllium. So if I add another proton, there it is, beryllium. Now I can't add a. So I've got the mass number of beryllium is 9. At the moment, it's mass number 4. So I need to add 5 more things. I can't add protons because that wouldn't. If I did, then it wouldn't be beryllium anymore. It would be boron. So I have to add neutrons. So keep adding neutrons until I get up to 9, and that means I would have to add 5 neutrons total. I've got a mass number of 9. To cancel out the charges, well, the protons I've got a +4 charge altogether, so I need to give it 4 electrons. And there we have it. The only thing to notice here as well is that beryllium is in group 2, which is the second column. So group is like column, and it's got 2 electrons in the outer shell. Whereas when it's neutral, that is, lithium is in group 1, and it had 1 electron in the outer shell. The other thing is that both of them are in the second row. So the first row is just hydrogen and helium. So how can we put electrons in this one? So the neutrons and the protons affect the mass. The electrons do not affect the mass. If you have a look, mass number of 9, take away the electrons, the mass number stays the same. Add electrons, mass stays the same. It doesn't make any difference. The electrons are extremely light, so they don't make much of a difference to the mass. But I wanted to also note that the second row has got all have two shells. So depending on what row it is, that tells you how many shells it's got. Depending on what column it is, that tells you how many electrons in the outer shell, in the most outside shell. So we call the column the group, and the period is the row. Okay.